re-recording the day 3 session and day 4 session, which we had missed earlier. It means that earlier I took the session, but we were not able to get the recording because there was some problem with the recording. So we didn't get the recording, saved recording. So today I will be continuing with I'll be just going through the day 3 session of Linux actually. Okay. So now I remember like day 3 session, I had took a lot of topics, lot of stuff like I had covered it. The same I would will be covering even today also. So on the day 2 session, like I just explained about how Linux was evolved. Okay, like for example, Linux was evolved by, or Linux was the Linux kernel was designed by Linus Torvalds. So he's a guy from Finland. So he designed the Linux operating system, and in the year 1992 or 1992, okay, the Linux kernel or the Linux operating system was released. And what the Linus Torvalds and his teammates they do, right? They maintain a separate site by name www.kernel.org. So this is a site where Linus Torvalds and his teammates maintain. So this site has all the Linux kernel versions released, like starting from 1.0.0 to whatever the latest kernel version we have, the 5 dot series or whatever. So those the whole kernel version series are being they have placed everything in the kernel.org. Okay, so that is a complete operating system which they upload it actually, and they do it once in 6 months. It means that every 6 months you could see in the kernel.org a new version of Linux kernel is uploaded. Okay. So now when this Linux kernels or the core part of your operating, that is kernel, if this kernel is uploaded into the kernel.org, so how exactly the other distribution works basically. So when the kernel will get released, right? There are many distributions are there. Like earlier, there used to be a version. There used to be a distribution by name Slackware. Now it's not there actually, but this was one of the first most distribution which was a primary distribution for the Linux operating system. To be that, what the Slackware used to do, right? They used to take this Linux kernel from the kernel.org, they download it, and they try to do a lot of customization into the kernel, as well as the Slackware will add their own uh, programs and everything. And finally, what they do, right? They will release in terms of the CDs actually. They release in terms of CD, means that they started distributing the CDs. So earlier, so usually what they do, right? Most of the enterprise distribution, right? What they do, they have the both the versions. So they'll try to release some open source free version as well as the paid version. Okay, so that is nothing but enterprise version. So even Slackware used to do that. So many times, like what Slackware used to do, right? There is to release the open version. It means that actually anybody can download freely the ISO image from the Slackware. So they used to visit that site and download that, and they used to get installed in their operating in their machine actually. So there is certain requirements are there, hardware requirements, like we need to have this many number of RAM memory, this much of hard disk, and this type of processor should be there. There's a requirement which is there. Based on the requirement, what happened, right? If the hardware requirement is fulfilled, what happened, right? You can able to install the operating system in your system, in your machine actually. So Slackware was one of the first distribution which they started providing the Linux distribution to all the universities, colleges, and many companies and all. They started distributing. So later, what happened after the Slackware? A lot of big companies came. Like for example, Red Hat was very big organization which came into picture, and this was now Red Hat, as you know, like it is acquired by IBM. So Red Hat was one of the very important distribution. And even the same, how the Red Hat used to do, right? They used to go to the kernel.org, they download the kernel versions, and they add a lot of programs, or they'll add lot of the server version. So Red Hat is basically famous for server editions. It means that suppose you want to have servers to be installed in your companies, like basically there are a lot of servers are there. For example, you have a DNS server, you have a Scoot server, mail server, right? And you used to have some NFS server, like you used to have Apache server. So there are many servers are there which everyone requires it. So Red Hat is very famous for providing the server edition. It means that if you go with the Red Hat, right, they will provide all kind of solution related to the servers. Actually, you want to install any servers, means yeah, preferable that you go with the Red Hat. Actually, even Red Hat also has its own sub organization like Fedora, which is again it's an open source. It means that actually it's a free version actually, right? Even we have a CentOS also, which is a free version. Okay, and the paid version or nothing but the enterprise version is RHEL, means Red Hat Enterprise Linux. So this is the paid version. Paid version. It means that actually this is not free. You need to pay a money for to buy the RHEL, and a lot of companies know they started working on RHEL because it's a very stable, a stable version which they provided, as well as if you want to achieve any kind of a server editions, right? In your company, there is a lot of requirement to install and set the servers. So Red Hat was most favorable actually. So people used to tend to go with the Red Hat only, and they used to go with the licensing cost itself because they'll get a lot of support from the Red Hat. That's what it means, that if they are working on some servers, like suppose I'm working on a mail server, I'm facing some issue in it. So Red Hat is there to provide a support for you. So that's our reason you should always go with the RHEL. So many companies they started going with the RHEL itself. It's a paid version. Okay, but some companies are there where yeah they have their product, but their product completely works on Fedora, so they'll be waiting for the new versions of Fedora to be released actually. So there are many companies are there who are working on Fedora or CentOS and all, so they go with that CentOS and Fedora are open source actually, but you will not get that much of support from Red Hat actually. So that's a reason what happened. Red Hat itself, they say that you go with the enterprise versions actually, like RHLs. Okay, so similarly, like that, there are many other distributions are there. Like you have a Ubuntu, you have a Nopix. Nopix, I think nobody is using Nopix more. You have a SUSE. Okay, so like that, there are n number of like distributions are there where they take up this Linux kernel, and what they do basically, all these companies like Red Hat, SUSE, and all, right, they try to release ISO images actually. ISO image. It is not, but it is a bootable image. It means that through the ISO image, you can actually install the Linux in your machine. Okay. So now, earlier, what happened very long back, most of the distribution, they used to give a hardware requirement. Like, for example, they used to say that, okay, the minimum requirement is actually your machine should be something like a x86 processor machine. Okay. And it should be minimum of two core CPU, two core CPU. Okay, or it could be a dual core. Okay, minimum of 4 GB of RAM should be there, and you should have minimum of 100 GB of hard drive. Like this was a requirement was given for everywhere. Like for example, whenever you want to install a full-fledged Linux, actually with all the features, like you should, I mean, it's a desktop edition you need to have. So then these are the certain requirements, hardware requirements, which always required before you start doing installation. Okay, so very long back, like these companies, right, Red Hat or SUSE or even like Ubuntu, right, they used to provide the CDs actually. They used to provide the CDs basically. So this CD is nothing but it is like a DVD CD drive just to give DVD CDs. So the CD is to have that ISO particular ISO image, okay, and all the installation softwares actually, softwares over there. So earlier they used to come with the CDs actually. Later what happened, right? They started uploading only the ISO image from in their site actually, and people whenever they want it, like suppose like I want Ubuntu very old version 12.04 or 14.04, right? I used to go to the Ubuntu site or website. There I used to download the ISO image, and get that or place that or copy that ISO image in the pen drive and make that pen drive as a bootable device. It means that as soon as I plug in the pen drive in my machine and if I reboot the machine, or else, suppose if you have a CD, if you have a CD, what you can do, right? You can put the CD, that CD-ROM into the CD-ROM drive, and like just reboot the machine actually. When you reboot the machine, what will happen that as soon as your system gets restarted, so what happens that the BIOS, right? The BIOS. So BIOS is nothing but you have a basic input output system. That because of BIOS. But BIOS is nothing but those are nothing but those are the initial instructions which get executed as soon as your system is powered on. So BIOS basically it checks for the bootable device. Like it'll try to check, okay, is there any CD, or is there any CD which is a bootable CD which is there in the CD-ROM. So it used to check for the bootable CD. Oh, is there any bootable CD which is there in CD drive? Yes, there's a CD. So what happened that it starts booting up from the CD like that. So as soon as it boot up the CD and it understand, okay, there is an information about the operating system in this bootable, right? It used to go into the graphical prompt actually, where it used to check. It used to go to the graphical prompt where it is to check like, okay, is this hard drive, whatever the user is installing, is it a new hard drive, or it has any other operating system, right? Like that. Because suppose assume that you are having a fresh laptop, like you have bought a new laptop and you want to install the Linux actually. Okay, so it doesn't have anything. So it understands that there is no operating system at all. So what it will do, no, it will show you that okay, this is a 100 GB of hard drive is there, okay, and the 4 GB of RAM is there, like that. It shows you to the graphical prompt. So basically, what the user is to do, right? User is to understand, okay, this is a disk used to have that is 100 GB. Okay, fine. So it will ask you whether you want to install the whole Linux. For example, I am taking Ubuntu. So suppose I'm installing the Ubuntu, like very old version, Ubuntu 12.04. It's a very old version. Okay, I won't prefer you to work on this, but I'm just saying you that if you go with the Ubuntu 12.04 or whatever, so it used to ask whether you need to install the Ubuntu into the complete 100 GB of hard drive. You say yes, sir. Then what it used to do, right? It used to start installing the Ubuntu under this whole 100 GB. Suppose assume that actually your hard disk drive, your laptop is having some 500 GB of hard disk drive. You are having some, you are having 500 GB of hard disk actually, HDD hard disk. Now, what you are having a plan is that actually that I want to install both the Linux as well as the Windows in my laptop actually. So I need a dual operating system. So what you said that okay, I will keep 250 GB for Windows and 250 GB for Linux. Like that, you had already made your mind to do it like this. Now what happened that you can either install anything. First you can install Windows on 250 GB, and the rest 250 GB whatever remaining your hard drive you can install Linux, or vice versa anyway. But always, right, it is always preferable that whenever you are having a dual operating system where Windows is also there, so I would suggest you to first go with installing Windows first, and then you can install any other operating system. Suppose like I have Windows I want to install, and I have to install even Ubuntu, or I have to install Red Hat, RHL4 or RHL5, anyone. So first I have to install Windows, okay, and then whatever the remaining hard disk is there, and in that hard disk I need to install Linux actually. So that is the best practice that first you install Windows and then you later install Linux. So there's a reason for that. So I'll be explaining about why we have to install first Windows and then later why you have to install Linux. We will discuss those things later. Okay. But what I'm trying to tell you is that actually that whenever you get an ISO image, you should, as a Linux user, you should also learn like how to install a Linux actually. Okay. Now we'll try to see what are the basic things you needed while installing Linux actually. Okay. Let me open a MS Paint and explain you certain concepts of your hard drive. See, now, if you go to the market, right, you have a lot of discs are there, lot of different disk types are there. Like earlier, like we used to get the ID hard disk actually. Okay, ID hard disk. ID hard disk were very old hard disk, so they were very, they were very slow, and like if you buy your desktop, right, like around 15-20 years back, right, you used to get the ID hard disk actually installed. So if you go to any computer shop and if you say that okay, give me a desktop, I need to have a desktop where no, I need to have my complete setup of the machine, right? they used to do setup, and inside they used to do a HDD hard drive, IDE hard drive they used to give actually. So that hard drive might be like 250 GB or 500 GB or whatever. Okay. So now, so what happened, right? When you get the desktop or when you get the machine which is having the IDE hard drive, right? So what happened, right? If you take any of the disk type, there are many other disks are there type, like you have a ATA drive, okay, you have a SATA hard drive also. So now it is a SATA hard drive are the most favorable actually hard drives. Okay, SATA hard drive. Even today also, if you are buying any of the laptop or if you're trying to go with the desktop, so it's always that SATA hard disk are given actually. So SATA hard disk are more faster working than IDE hard drive. Sorry. So nowadays IDE hard disk are not available actually. Only SATA hard disk are available. Okay. So if you take a hard disk, suppose I have a 500 GB of hard drive. Okay. Suppose for example you say, Rajesh, I have 500 GB of hard drive. I have 500 GB of hard drive. So in this 500 GB, suppose this you consider as a 500 GB hard drive. So you take any hard disk actually, you can create a minimum of 4 primary partition. You cannot, not minimum, you can create a max of 4 primary partitions. You cannot create more than 4 primary partitions. That is the nature of each and every disk, right? For example, if you take this disk, right? So what you can do that you can create a partition like this. First partition, second partition, third partition, and fourth partition like that. So this is the first partition. Assume that this is a 500 GB hard drive. Okay, so you will create a partition, right? So like that you will create. Okay, four partitions you'll create. Now, even if you take ID hard disk or SATA hard disk, you can only create 4 prime partition. You cannot create more than 4. I cannot create fifth or sixth or seventh partition. It's not the hard disk will not allow you to create it. Only 4 primary partition would be it get created. Okay. So this partition, but it is but it's a logical isolation of a area actually. We call it a partition. Okay. So in Linux actually, if you want to create a partition, there's a utility known as a Fdisk utility. So using that Fdisk utility only, you can create a partition. Okay. So if you are having 500 GB of hard drive, okay, assume that you are having 500 GB. You can say that Rajesh, the first partition, I'll keep it as something like okay, I'll keep it as 150 GB. The second partition also, I will keep it as 150 GB. And the third partition, I'll keep it as 100 GB. And the fourth partition, I'll keep it as 100 GB, like that. So 250, 150, 150 plus 100, totally it will be 500 GB, like this actually. So, and these are the 4 private partition you can create. As I said, you cannot create more than 4 private partition. Any one partition, you can make it as a logical or extended partition, right? So this partition, suppose this is the last partition, you can make it as a logical or extended partition. It means that you can take this 100 GB. Again, what happened is you can create sub partitions like this actually. You can create a sub partitions like this, like this. You can create some more part. It means that if you say Rajesh, the 100 drive is there, can I create a 5 sub partition like 20 GB, 20 GB, 20 GB, 20 GB? Yes, you can create like that. So this we call it as a logical or extended partition. So this partition, this will be a 20 GB of partition. I'm just taking. Oh, it means that you can create some more sub partition like this, 20 GB, and this is 20 GB, like that. 5 partitions you can create again. So any one partition you can make it as a logical or extended partition, we say. So suppose I'm considered this drive as a logical or extended partition, I can create some more sub partition. So in the SATA hard drive, like that, what they say that you can create up to 14 logical or extended partition. Like that, you can create it actually. So if somebody asks you like how many number of total partitions you can create in SATA disk, actually 14 here plus 3. So totally 17 partitions you can create in SATA hard drive like this. Okay, guys, 17 partitions can be created in the SATA hard drive. That's what it is. Okay, ID are there. You can create 64 partitions in ID. ID was supporting more number of partition creation. So now, if you're having a hard disk like this, and you say that Rajesh, I want to have an install Linux as well as a Windows, both I need to install it actually. Suppose you take a Windows CD. So you have a Windows, Microsoft Windows. So you will purchase the Windows CD, professional CD or home edition, whatever, and you put a CD onto the CD drive and then just try to reboot the system. So what happens that BIOS will check that okay, under the CD there's a CD drive is there, which is a bootable device. Oh, so what is that? It is a Windows bootable device. So now what happened, right? It will try to check that hard disk that, oh, okay, there are already partitions are there. So user has created a partition. Okay, fine. So now what happened, right? So you know that in Windows, whenever you want to install Windows, basically Windows expects minimum one drive, that is a C drive, correct? So C drive is required, and for the C drive, it always requires a primary partition. So what you said that okay, fine, I want to install Linux Windows here. So I will make this first primary partition to be installed the Windows actually. So here what happened, literally your C drive will get installed over in this partition. So it means that the C drive is a primary drive, or it's a drive where you will have all the information about your operating system, Windows operating system, about the systems, about the libraries, about the drivers. So you could say that the whole soul of your Linux of your Windows operating system, it lies in the C drive itself, because C drive is the ultimate partition where you will have all the information about your Windows system, like that. Okay, so you can install over here actually. Then you said, Rajesh, I want to create one more free drive where I can keep all my like personal files and directories and everything. So okay, you can consider this 150 GB as a D drive like this. So it means that basically you have covered using the 300 GB of your hard drive for only installing Windows. So this has the Windows. Complete Windows is used by your C drive and D drive. Correct? So this is not your Windows. Suppose you install Windows 10. So Windows 10 will use both C drive and D drive. Correct? Now remaining 200 GB, whatever you have remaining 200 GB, here you can install, actually you can install your Linux. You can install your Linux. Suppose you are taking Ubuntu as a Linux, right? I want to install Ubuntu. You can install in the rest of your remaining hard drive, you can install your Ubuntu. Okay guys, here you can install Ubuntu. Now, as I said, right, Ubuntu by default, it can take up the whole 200 GB and it can install it over there. Okay. Now, but that is not correct way. It means that suppose any Linux user, he want to install Ubuntu or he want to install Red Hat, right? So with whatever available disk space he want to install it. So what he will tend to do, right? He will tend to first create the partitions actually. Partition means he want to first create a drives actually. Drives or partition means while creating it, he will try to tell that okay, what kind of a partitions I want to create. In Windows, you know that the primary partition is number C drive. So while installing it, it'll ask for the C drive and it'll install it actually. Similarly, what happened in Ubuntu, right? Whenever you are installing Ubuntu or whenever you're installing any Red Hat flavor, right? It always expects minimum one file system, which is number slash actually. So slash is a file system, we say. Okay, you can have the whole Linux in your slash itself, or else sometime what happen usually people will tend to give different partition. Like for example, so slash they will give. I will say that okay, Rajesh, I will give slash as 100 GB because it's ultimate. So slash is a main partition which we created actually. Okay, in Linux actually, slash is same as your C drive actually. Like how we have a C drive in Windows, no. Similarly, slash is a drive which is the ultimate drive, or it's the ultimate file system of the Linux operating system. So we'll tend to give some more. Always we'll tend to give large big space for always slash. Apart from slash, what are the other partitions which you create actually? Okay, I'll give 100 GB for the slash. Okay, so you'll also give a separate partition for the slash home. Maybe depend upon your disk. Suppose my disk is abundant, I'm having 1 TB hard disk. Okay, I can give up to 500 GB of my hard drive only for the slash home. Okay, fine. I'm just taking some numbers, sir. Don't go. I mean, just you might say that Rajesh only 200 GB is there. How we can get it? I'm just saying that based on your depend upon your disk size, you can allocate, right? So here and afterwards, what are the other partitions you can create? Separate partition, like for example, slash USR. You say that okay, I'll give 150 GB. Fine. You will create a separate partition for slash var, which you'll give as something like 100 GB. You'll also create some swap partition or swap partition, which is nothing but double the RAM size. If your RAM is 4 GB, so assume that your RAM is 4 GB, a swap will give 8 GB actually like this. So double the RAM size is what you will give for the swap partition, swap area. So most of the time, like user usually don't give the swap partition, they will leave as it is. Sometime what happened, right? During when the people who are installing Linux in the company, like in the enterprise level, right? They tend to give the swap partition always while creating it. Okay, so in this, so we just took the number. Okay, we just took the partition name. Okay, so but you said that Rajesh, without slash home slash or where can you install it? Only slash is there. Can I have a the complete Linux operating system only in slash? Yes, you can have. So slash can only slash can be existing. I don't need other thing. Yeah, that is fine. You can keep it without the slash home slash or slash var or swap. Right, still your slash is there. It means that you are having a Linux operating system. You can happily work on that. Okay, but what will happen that usually what happen, people will not only give slash, they'll give you this partition also, separate partitions. Okay, slash home separate partition, slash user separate partition, and slash var separate partition. They'll tend to give this. Okay, now so these are nothing but these are all the ultimate file system of your Linux operating system like this. Okay, guys. So now, so assume that in this 200 GB your entire Ubuntu operating system is installed. So now what will happen that this is nothing but a disk actually, the complete disk. Here what happened, right? Here, uh, here apart from this actually, here you have something here like one sector will be there. This we call it as a MBR actually, master boot record actually. So here master boot record is a place where your the initial boot the initial boot process, okay, boot process or boot loader, it is there actually. Okay, so whenever you install Windows and Linux, right, what will happen that when you install Windows and Linux, what will happen that by default the Linux has a Grub bootloader. The Linux has the Grub bootloader. The Linux has the Grub bootloader. Grub we call it as a Grand Unified Bootloader. So a part of the Grub bootloader, which is Linux bootloader, which is Grub, a part of it, not completely, that would be there in your MBR. So the MBR has a part of Grub bootloader. Okay, right? So what is this bootloader? What is this MBR and all? We will get into much more extension in the next session. But I'm just trying to tell you that actually, so you always what happened if this is your hard drive, the first sector of the hard drive starts with the MBR actually. Rest other all other like uh, the rest other size of the complete your hard drive where you can create the partitions and later you can even install operating system also. Okay, so what is this grub, what is this everything will come to know later. Okay, so this is what the like the hard disk architecture would be. Okay, I just took the number like it, if it is a 500 GB nowadays, you know that people are not happy or not, they need more and more, right? Some people need 5 terabyte of hard disk, some people need 10 terabyte of hard disk to require, right? So 500 GBs and all are gone case because nowadays hard drive are becoming more and more cheaper every day. So people will tend to go with the higher hard disk actually. Okay, so what happens, right? Like for example, this is the partitions which we have to create while installing Linux. Okay. Okay. So now what we are doing here, I'm not showing you like how to install Linux and everything. Like you can learn by your own actually, because I don't have that setup where I can show you the Linux, but it is a pretty simple, simple process of installing Linux. So whatever I told you, right, it will be keep asking you from the input from the user that, okay, what drive you need. You say that I need to create a slash drive, okay, slash partition. Then you'll ask you what is the size, like that, and it'll prompt you which is the next drive you need. I have to give slash usr like that. It keep asking you, or else you say that I don't want anything, I want only the slash partition. Then it immediately start installing actually. Okay, now in our session guys, what we are going to do here, so it means that we see whenever you can take up your a laptop, if you have a free drive, you can install your Linux into that existing free drive. You can do that. Or else people usually what they do right nowadays, they go with the virtualization. Like for example, what they'll do, they will tend to they'll install the VMware or they will install the Oracle Sun Virtual Box machine. On top of it, what will they do, right? They will try to install Linux actually. So this Linux, remember, it's a virtual image actually. It's a virtual machine, we say virtual machine. So you can do that way also. So it means that you can go and install your Sun Virtual Box or VMware in your Windows. And on top of that, what happened with the help of this virtual box, okay, you can install any kind of an operating Linux operating system, either CentOS or Red Hat or Fedora or Ubuntu, any image you can install it. So again, the process is same. It'll ask you for the partition. It'll ask you some details and all. It'll ask you the time settings. Or you are from which zone, like you are Asia Pacific. So many things it asks initially while installing it. So it's a pretty simple process. I'm not doing here. But what we are doing here, I'm not using the virtual box. I'm not using this VMware everything for my upcoming classes. Okay. So what I will be doing, right? I will not go with this. I will go with the AWS actually. It means that basically I will try to procure a Linux machine from the AWS cloud actually. Okay. So as you know, many times I've used that. I log in into the AWS account, and then what happened that I will launch the EC2 instance actually. Launch the EC2 instance. So EC2 instance is a service through which you can procure the VMs actually. So it means that I will try to like I will try to launch a Linux, something like I'll try to do. I'll go with the RHL7 Linux actually, and then I launch it, and I will try to, after launching, after it comes up, I will log into this machine and show you the complete understanding of how Linux works actually. So it means that basically just from the AWS cloud itself, I can able to take one machine and show you everything. But what happened, right? There are many features are there. Like for example, like you need to go to the graphical prompt, okay, or else you have to go to the command prompt. These things and all you will not be able to achieve with that. Why? Because in that case, like you should go with either with installing your Linux in your in your laptop itself, like based on the availability of the hard disk, or else install the some virtual box machine and install the VM actually. Through that way you can actually go to the command prompt or graphical prompt. You can really enjoy getting into this prompt and working. But here we have a restriction, because in the Amazon Linux, right, what we are taking from the Amazon cloud, right, we will not be able to get, you will just get one terminal actually. So that is a Linux terminal, that is not, but it's a shell terminal we'll get. So through that itself we will be working on that. So we will not be able to really really understand about how the graphical prompt works or command prompt works. I could able to only explain you a theoretical way of how things works over there. Because here, okay, I'll do one thing someday. I will show you in a virtual box also how to install and everything. But as of now, I will not be able to show those things. So what I will do, so I will launch the Linux from the AWS cloud, and I will show you how to log in it. We already know that how to log in it. You need to have a PEM key, and or else you can have a generate a PPK. Through the PPK key, you can log into that machine actually. So there you'll get a terminal actually. Okay. So now here, usually what happens as soon as you install Linux, suppose you are in Sun Virtual Box machine, as soon as you on Linux actually, by as soon as you install the Linux, it will try to reboot the machine once. So once the system is rebooted, assume that once the system is rebooted, it will show you, it will show to the, it will show to the user that your machine has the Linux operating system. It's something like you have installed Ubuntu, so it will show that Ubuntu operating system is there in your machine like that. Okay. After that, what happened? That you'll click on that. You want to say that okay, I want to boot the Ubuntu image. Okay. So what happened? The booting takes place basically. Okay. So what is this booting and all? We will discuss after some time actually. So booting is nothing but you are able to boot your operating system. It means that basically you're trying to make or you're trying to do a loading of your compressed image of an operating system into your system. It means that the image will be there in the disk actually. While booting, it means that you're making a system up. It means that what the booting will do, or the boot process will do, it will load the image of your compressed image of an operating system to the memory. And once it comes to the memory, and once the system gets started up, then only you could see that in your screen, you could see that your system is booting. Finally, you'll get a prompt where you can log into the system. It means that you have to give some username and password. As soon as you give username and password, username and password, you know very well that actually you are able to log into the machine, or you are able to log in inside the machine. So the whole process until the system get initializes, and it will try to load the operating system, and finally it will come to a stage where you need to log in into the machine. Till the whole process we call it the boot process. So we have a separate topic on this boot process, which I'll be explaining in a very upcoming class. Still now I have not yet covered those things. Maybe at the end of when we are near to the end of our course, right? At that time I will be taking care of this, even these topics also. Okay. So what we are doing, right? So whatever I'm theoretically saying, suppose assume that if you are having a Sun Virtual Box machine, it means that in your machine you have installed the Sun Virtual Box, and on top of that you have installed Linux. So it boots up actually. Once it boots up, basically it will get into a graphical prompt. It'll go to the graphical prompt. Okay. Okay, it'll go to the graphical prompt. So graphical prompt means it is also one of the prompts where the user can log into the system and he can start launch the terminals and everything. He can work with the system. That is what it is. So basically in Linux, you will get both the command prompt as well graphical prompt. Hold a second, guys. So you'll get the graphical prompt as well as you will get the command prompt actually. Okay, so you'll get both the prompts, so you can work anywhere. Both are same actually. Graphical prompt is where you can do some kind of a graphical operations. Okay, okay. So later I'll show you guys like how I can install Linux in the Sun Virtual Box machine. So I'll install Sun Virtual Box machine. On top of that, I'll install Linux and I'll show you how things work. Just a minute, guys. Sorry, guys, there was a call. So so later, as I said, later I'll show you guys. So you will really appreciate how things works in the Sun Virtual Box machine. But as of now, I'm theoretically explaining you. So in the graphical prompt also, you can log into the graphical prompt and you can launch your terminal actually, or you can open the terminal. Okay. So usually what happened, right? Usually when you have a full-fledged desktop operating system Linux installed in your laptop, so you will have six command prompt six command prompt and one graphical prompt you will have. Okay, so it means that PROPMT. So for example here, guys, like for example the function key F1 to F6 actually, like function key F1, F2, F3, F4, F5, F6, right? This is used by the command prompt actually, and the F7 key or F7 key function key, okay, it is used by the graphical prompt. So when you have logged into the system where you are seeing graphical prompt, it means that your operating system, it is running under the F7 function key. Okay, so that is a key where where your graphical prompt will be working. So you can actually toggle between the graphical prompt and the command prompt and everything. For example, by just pressing Control plus Alt plus F1. If you do like this, you will get into the first command prompt like this. Similarly, you can say Control plus Alt plus alt alt plus F2 function to F2 means function key F2, then it will go to the second command prompt like that guys actually. So now you say that Rajesh, I want to come back to my graphical prompt. You have to say control plus alt plus F7. If you press the F7 key, right, then you will come to the graphical prompt actually. Like this guys, you can actually move toggle anywhere between the graphical prompt to the command prompt and all. So that flexibility, everything you will get if you have installed Linux in your laptop, right, in your laptop or in your Sun VirtualBox machine, anything, okay. But you'll not be able to get all those features from the AWS cloud because that AWS cloud will just give you an instance. It means that you can just able to log into the machine by using any of the like either using the putty session or xterm or mobile xterm or anything or super putty. Through that only you can able to log into a terminal. You won't get this kind of facilities in your AWS cloud actually. Okay, but whereas you are installing separately Linux and all in your laptop, okay, you will be able to get all this command prompt, graphical prompt, everything. Okay, this is one thing. So this, as I said, right, I'll not be able to showcase now actually, right? Now, so that's all about this one. And like this hard disk, right? This is not but the hard drive actually. If you take the hard drive, right? If you take the hard drive, suppose if you take a 500 GB hard drive, right? This will be like a hard disk actually. This is like a hard disk actually. So this we call it as a magnetic disk platter, guys. This we call as a magnetic disk platters actually. So suppose if you take a 500 GB hard drive, you take a drive, open the drive, just you open the drive, just there will be a lot of 3-4 screws will be there, just open and see it, right? How it will be, it looks like this will be there. Something like there will be some 3 discs will be there like this. 1 disk, 2 disk, like this, 3 discs will be there like this. 3 discs will be there like this. And there will be something like a arms are actually, ARM, we call it arm actually, like this will be there, arm. And here what is happening that some kind of a spindles will be there like this, like this. Spindles will be there like this. So these are the spindles which actually read the disk actually, like this. Like this spindle should be there like this. So this is we call as a disk. This is another magnet disk platter. This we call as a ARM arm. Sorry, this we call the ARM arm. This we call it as a spindle. And this tip pin, no, the tip right here. This I'm talking about, like this tip pin, no, which actually read the disk. This we call as a head actually. So like this, so assume that this is the 3 disks here there, and this total 3 disk is nothing but this is a 500 total GB is a 500 GB. So this is nothing but this is the magnetic disk platter is there actually. So like this, if you open a hard drive, you could see that inside either 1 or 2 or 3 disks will be there. So if you take this, suppose assume that you are taking this only this you are taking actually. So you're saying that you are taking this disk and you're showcasing that so this is the magnetic disk platter. So basically, this is a magnetic disk platter which is coated with a magnetic ink. It is what it's a this inside, no, it will be coated with a magnetic ink actually. So what happened, right? Always what happened, right? All your data, all your system data or whatever data, right? It is always stored in this disk platters actually, in the form of concentric circles known as the tracks. Suppose you take this like this, there are a lot of tracks are there like this, like this. A lot of tracks are there. Sorry, a lot of tracks are there like this. Oh, okay, this is one track. Okay, this is one track. Okay, like this, one track. Like this, there will be a lot of tracks will be there, sir. Actually, tracks like that. This we call the tracks actually. So if you take any disk, right, it will be usually having 1,728 tracks will be there in each and every disk actually. So a single disk will have 1,720 like this. How many counts will be there? Like 1,720. printed disk tracks are there actually. So what usually happens is that these tracks are actually divided into equal number of sectors actually. These tracks are divided like this. It is divided like into this equal number of sectors like this. Right? And this this portion what you're seeing here, this portion what you're seeing here, this portion, sorry, this portion we call it as a sector, one sector. So one sector is always 512 bytes. Okay, guys. So like this way we have it, it means that there are many sectors. This is one sector. Okay, this is one sector like this. This is one sector like this, like this. This is one sector like this. So these are sectors actually. So sector is always a fixed size. So if somebody asks you what is a sector, you say, sir, sector is not about 512 byte. A sector is a minimal addressable unit of your storage device. So a sector is 512 bytes. Always, it is always 512 bytes. It is always, sorry, it is minimal addressable unit of your storage device. So it means that whenever you take a disk actually, what is the minimal addressable unit of your storage device? Is not, but it is a sector. It means that you can have. It means that suppose you go with the diagram, and if you see that you could see that this is the head actually. I have written that head right. Head is the tip of the spindle is the head where it will read the sectors actually, or it reads the track actually. Okay, that head can actually read one sector at a time. It cannot read less than one sector. Suppose assume that you say that Rajesh, I create a file. Suppose I say touch Alice, I'll create a file. So Alice file will be created, right? Minimal, if a system or the operating system has to assign one sector for that file. It cannot, it cannot store or it cannot give less than one sector. Suppose you say that you create a file Alice, touch Alice, and inside the file Alice, suppose you say vi Alice, you'll open the file and you'll just store only one character A in that file, and you'll just say later you'll say WQ exclamation, save and quit it. So you're just storing only one character inside a file Alice, right? You are creating a file and you are creating only one file, only one character in the file. So what is the disk will be allocated for the file Alice? Or minimum of one sector should always be allocated, sir. So it means that it is a minimal addressable unit of your storage device. It means that the head, whatever the spindle head is there, it can read one sector at a time. It cannot read less than one sector. It means that you say, Rajesh, I have written a file Alice, I am only one character there. So let this spindle or the head reads only one character in the disk. No, it cannot read just one character. It should always read one sector at a time. It means that the head or the tip of this spindle is head, it will always read a sector, one sector at a time. It cannot read less than one sector. So that's what we say sector is not, but it is a minimal addressable unit of your storage device. We call it as a sector. So it means that these whole disks are there, right? These disks are nothing but these are nothing but it is having a lot of tracks, and this lot of tracks is given to equal number of sectors, and each sector is a 512 byte like that. You have to understand. Okay, it means that Rajesh, if I'm having a 500 GB of hard disk, it does it mean that it has many sectors together? We call as a hard disk. Yes, sir, many sectors together. How many sectors are there? We will see later all those things. Like there will be a lot of tracks, lot of sectors will be there. So all these sectors together make make your hard drive actually. Okay. Now, so what we say that actually that when it comes to the file system, okay, file system. When it comes to the file system, when it comes to file system, always file system deals with the blocks actually. Always it deals with block. So it says that actually we say that 512 bytes, that is one sector, plus 512. 512 plus 512 bytes. It is nothing but 1024 bytes, or approximately one block size. We say. So two adjacent sector, two consecutive sectors make one block. So 512 plus 512 will make one block. So which is 1024 bytes. So this we call it as a 1K block size. We call it as a 1K block. So like that, we have a various block size. We have 1K block. Okay, we have a 2K block like this. 2K block means how much? Four sectors. Like here, 1K means two sectors. Two consecutive sectors make one block, right? 512 plus 512. You have one more block which is called the 4K block. 4K block is nothing but what? 1024 plus 1024. So 1024 bytes plus 1024 bytes is nothing but 2048 bytes, which is nothing but 2K block size, we say. So 2K block size in turn how much? In turn four sectors, right? So four sectors together will make one block as a 2K block size. Similarly, we have one more block size in nothing but 2048 bytes plus 2048 bytes is equal to 4096 bytes. Is sorry, 4096 bytes, which is approximately 4K block size. Now you could say that how many sectors are making 10 4K block size, sir? So two block 1024 plus 1024 is not but 4K block. Four sectors make in 10, right? Right? So like that way, how many sectors will be there in the 4096 byte? 8 sectors will make one block as a 4K block size, right? That's how you have to understand. It means that 8 consecutive sectors make one block which you call as a 4K block size. So file system will always understand in terms of blocks. So either the file system works with the 1K block size or either the 2K block size or either in the 4K block size. We even have 8K block also, but that is not preferable. 8K block size is also there, but which is not preferable. So in the file system is not good when it comes to the 8K block size. The file system perfectly work if the block sizes are 4K block size or 8K block size, or sorry, 4K block size or 2K block size or 1K. So I could see in the industry like most of the time what is happening that either it will be 1K block size or 4K block size, but maximum it will be a 4K block size. Now there's a theory, or sorry, there's a formula actually. They say that actually that what is that formula means? Suppose your hard disk, or suppose your partition is uh, suppose if your suppose your partition is greater than 100 MB, always 4K block size will be assigned to that file, to that partition, always. So whenever if your disk size is above 100 MB, always what happened, the file system size or the file system block size will always be 4K block size. If the partition is lesser than 100 MB, so the file system will assign 1K as a block size. So it means that I'm taking a 100 MB or less than 100 MB. Suppose a 90 MB hard disk I'm taking. I mean one partition of 90 MB, and I'm creating a file system on it. By default, the file system will decide that oh, it has to give 1K as a block size. Suppose you are creating a file system for a partition size greater than 500 MB, like 1 GB, 2 GB, 10 GB, 100 GB, 1000 GB. So when you create a partition of 1000 GB or 500 GB, one partition of 500 GB, and you create a file system, that is Linux file system, automatically the file system will assign a 4096 as a block size for that file, because the size of the partition is greater than 100 MB, right? So whichever disks are, like suppose you take 1 GB of hard drive and you create a file system on 1 GB of hard drive, by default it will assign a 4096 as a block size, like that. Less than 100 MB, 100 MB, like 90 MB, 80 MB, 70 MB, 50 MB, always the blocks will be 1024 block size. It cannot assign a 4K block size over there. Okay, so this is what it is. Okay, now okay guys, so now that's how it is. It means that actually whenever you are installing the Linux operating system, you'll be installing the Linux operating system in terms of partitions. Like this, partitions will be created, and the partitions are nothing, it is not, but it is a number of it is number in terms of sectors. You can say that oh, I need this many number of sectors, it means that I will get this number of GB of one partition, or else you can even talk in terms of cylinders, both. So you can either give, while creating a partition, You can either give in terms of cylinders or in terms of sectors actually. So that you'll get to know when we are installing Linux actually. You might not be able to completely understand now. If suppose some people are very new to this and they are not able to understand. So while installing the Linux operating system, right, you will get to know everything. Okay. So the people who already know it, I think they are able to understand it very clearly, whatever I'm saying. Okay. So that's how the hard disk is. This is how the hard disk look like, and we can create a partitions and we can install the Linux or Windows operating system, everything into the machine actually. That's all. Okay. Now here in our case, what I said, right, I will be taking up the Linux from our AWS cloud, and I'll be working on that actually. Okay. And here we will be learning about the architecture also. We need to learn about the Linux architecture, how the Linux architecture works. That you need to learn actually. Okay. And also we need to learn about what is the user space and kernel space. Though in the other videos I have really covered all these things, but still as a part of explaining you clearly what we did on this day 3 session, I have to explain you about what is the user space and what is the kernel space. Okay. Now, and also we need to learn about few commands actually. We should start with a few commands actually. Okay. Now already I have launched the Linux actually in my AWS account. You could see that this is a Linux machine actually. So if I connect to this machine, or I already have, I'll try to copy this public IP, go over here, launch the putty. I'll just copy it here, and so you could see that I'm able to log into this machine now. So this is not, but this is just a terminal, guys. So I'm able to log in with the EC2-user. So you could see that I'm able to log into this machine. Okay, this is my Linux machine actually. Okay, I've logged in with the username EC2-user. Later I can switch to the super user or the root user by using sudo su-root or just say sudo-i. Anything, you are able to log into the root user actually. Okay. Now the first command which we will see is a uname command. If you execute a command uname-r, this will show you in which kernel version you're working. You could see that right now you're working under 4.18.0. That is a kernel version which you are working on now. Okay. Or else you can even execute the uname with a -a option. So this will give you some more extra information. Apart from the version, it will give some more extra information. Like, for example, this is a Linux operating system, and this is nothing but this is host name actually, complete host name, and this is the kernel version, and this is another SMP architecture, on which date it was installed, like we have, right, on which platform it has installed, like x86 architecture, like this, and it is having a GNU Linux actually. So this is what you will get the full-fledged information, right, when you execute uname-r. And also, like, you can even check which is the operating system which is running. You can just say cat of /etc red hat-release. This is a file. If you open it, you will get to know that okay, it is having a RHL 8.4 Opta. So this is the version actually which is there in your. So basically, I try to when I try to launch the machine, right, in AWS, right, I choose the RHL 8 actually. So under that RHL 8, like, I have just booted up, just logged into the machine. So you can get to know about the version by just saying cat of etc red hat. Okay. And after this, what happened, right? I need to check what is a terminal, on which terminal which you're working. If you do the command Tty command, you could see that it is showing you /dev/pt0. It means that you are into the 0th sudo terminal. Clear, guys? Suppose assume that I'll try to open one more. I'll try to duplicate it. Okay, I'll open it. I'll log in as root itself, and I've already assigned the root password as Red Hat only. Let's see if I'm able to log in. Okay, I think I'm not able to log in it. Okay, I will give the EC2 user itself. Okay, I'll give EC2 FN user, and then, like, I'm able to log in now. Right? Okay, I can do a switch to the root user by using sudo-i. Right, and I can I can check the command Tty command. You could see that it is showing as /dev/pt/1. It means that this is the first sudo terminal. This is zero terminal. Like that way, these are terminal names. Okay, what is the terminal names? We'll discuss later. It means that as soon as you get a terminal, always the system assigns some terminal name actually. So in Linux, how many terminals you can create, like the sudo terminals you can create? They say that. So I have executed uname command. Okay, uname -r command or uname command, uname -r, and also uname -a. So these are command I have executed. Now I execute tty command. Tty command will show you on which terminal you are working. So like for example, it will show if you execute the tty command, it will show that you are working under /j/pts/0. But whether this number, this is the pseudo terminal. We said pts means pseudo terminal. Pseudo terminal. So you are under the 0th pseudo terminal. So similarly, I have launched one more terminal, and when I execute tty command over there, you could see that it's showing a /dev/pt/1. So that's what. So this is the first pseudo terminal. Like that way, there are n number of pseudo terminals you can open. What they say, Red Hat says that you can even open up to 255 pseudo terminals actually. Pseudo terminals can be opened by a user actually. So many users you can terminal open, sir. You can open so many more terminals like that. So like that. Okay. So what we'll be doing in upcoming classes, right? You have seen that in my other sessions that I have covered a lot of commands I have covered. Okay. So those commands and all we need to execute, we need to understand through the command also how the system works and all. Right. And also like I will be explaining you about many more core concept of Linux. Like for example, I'll be taking a storage also. Storage is nothing but I'll be taking about how exactly we can configure LVM, the logical volume managers, and related to that actually. So this is a very interesting topic which we'll be covering in the upcoming classes, as well as we have to cover the core part of networking. So how networking works in Linux, that also very important. Around 1 or 2 sessions I'll be taking only on networking part, as well as we need to be taking about the user management, system management and user management like that. Okay. Now here you could see that actually that you have logged into system with the help of EC2 user. So EC2 user has logged in actually. Okay, and you could see that this is nothing but the host name. If you execute the host name, so it could see that this is the host name of your machine. Okay, this is the host name of the machine. Whenever the root user logs in, you could see that at the end you'll get hash. Whenever a normal user logs in, like EC2-user act, you could see that dollar. So with this symbol also you can understand whether this user is a normal user or the root user. So you could see, if I'll just exit out, you could see that he's a normal user. And you could see that at the end it is always getting dollar. Oh, it means that he's a normal user. Like for example, I create a Rajesh, Mahesh, Suresh, Naresh. If I create, right, all those are system normal users actually. While after logging into the system, you could see there's a dollar here at the end of the prompt. So this signifies that you are a normal user. Suppose now I switch to the root user. I say sudo -root. See, you switch to the root user. See, for the root user, always it is numbered hash. So with this symbol also, you can identify what kind of user he is actually. Okay. So now guys, what we are going to see the next is that actually we are going to see that what is an architecture actually. It means that suppose for example, when you boot up the system, what exactly happens? Okay, right. So we'll be discussing about a little bit about the Linux architecture now. So guys, these are the upcoming classes which I'll be taking in the session. You need not to worry. I've still not yet covered it. This and all I have to cover in the upcoming classes. Okay, but all these are very interesting topic. We should know all these topics if you're learning Linux. Okay. So now Linux architecture actually. This also in many of the other sessions like day 5 or day 6 I have covered it, but okay, I will give a small introduction in this session today. Okay, Linux architecture. Okay, and also we learn about what is the user space and kernel space. So these are very important, sir. We need to learn all these things. Though I have covered everything. Now what happened, right? As suppose like you have your laptop and assume that your laptop is having a Linux operating system or Windows operating system. So what you'll do, you'll try to just start the machine actually, or you're just going to power on your machine. So what happened, that as soon as you power on your machine, okay, we say that actually the booting takes place. We say. So booting takes place means, it means that what booting takes place means. So as soon as you power on, what say that? You say that, Rajesh, as soon as we power on, as soon as we power on, the system boots, we say. It means the operating system is getting loaded in your system. Correct, guys? This is what booting means. The operating system will get loaded up. But there's a big process is there, how exactly the operating system loaded, how the things happen. That all those things are covered as a part of the boot process section. Under the boot process section, I will explain about how exactly the booting takes place. For every Linux user, whoever is working on Linux, it is always better that you should also know, or you should also understand how exactly the boot process takes place in Linux system. Actually, it's not only Linux, any operating system. Suppose you're working on Windows, you should know how the boot process takes place. So if you're working on that level, right, where you're working on many things about many things operating system, you should never miss about the boot process. It is very important. And I would tell that many times what happen if you go for interview. So any one of the interviewer might ask you like, do you know how the boot process takes place in Linux? Can you tell me the steps, or can you write down all the steps? So they will tend to ask all those things. So it's not like that. You know only commands, or you know only scripting, that is up here. No, there are many other aspects of operating system there, which the user should know it actually. Okay, that you should know it actually, because these are all very basic things we should understand, and also it will help you to understand if you know all those things, other things, right? Like for example, I know boot process, I know kernel recompiling, I know about the logical volume manager, I know about how to configure the networking, how to configure the storage, I know about the user management. These are all many extra things about the operating system or the Linux system, which if you have a knowledge, right, you can understand the system in a better way actually. That's the reason we say that, okay, you should know all those other things also. Okay, now, so what happened, right? The booting takes place. It means that actually, basically, the your compressed image of an operating system, right? It will be there in the hard disk actually. So during boot process, what happened that your compressed image of an operating system, right? That will get loaded into your memory. So loaded into the memory means it will be loaded into the RAM memory. So you know that in a system we have a RAM memory. RAM memory we called as a primary memory. Hard disk we call it the secondary memory. Okay, so hard disk is nothing, it is a secondary memory or external drive where we will store the data, right? RAM memory is nothing but it's a primary memory, right? Primary memory where your operating system will be running, where the user will be working, or user logs into the system and working, right? That is nothing but it's a RAM memory, we say. Now usually what happened, right, during the boot process, so you have a RAM memory. Assume that this is your RAM memory. This is your something like your 8 GB of RAM memory. This is not but your 8 GB, or I'll write it at the up here. It is a 8 GB of RAM memory. Literally, this RAM memory, this will get divided into two space like this. It will get divided like this equally, not equally. I will tell you the ratio later, but it will get divided actually. So this upper section, we call it as a user space. Actually, many times I use this word user space. Okay, and this lower space, lower the downwards, we call the kernel space. You can even call it as a user mode and kernel mode, but usually we always use the word user space and kernel space. Okay, now what is happening that here, this is your hard disk actually, where you have an information about your operating system. It means that your compressed image of the operating system or the kernel or the operating system will be there in the hard drive. So what happened, right, during the boot process? So this, assume that this is the boot process actually. So this is the boot process. So I'm just writing, this is the boot process actually. So you say that, Rajesh, this is a boot process actually. It means that there are some steps are there. So boot process. What the boot process will do, boot process will try to go into the hard disk. It understands where is exactly the image of operating system is there. Okay, there's the image of operating system is there. So what it will do, it will try to load this operating system into the kernel space of the RAM memory. Like this. So here, in the kernel space of the RAM memory, your operating system will be loaded. So this operating system will be a compressed image. It will not be like a uncompressed. It will be always in a compressed image. So this operating system is what we call as a Linux kernel. Correct, guys? We call this as a Linux kernel. So the Linux kernel or the Linux operating system will be loaded into the memory. Okay. Now Once it gets loaded into the memory, after it gets loaded to the memory, okay, what happened? The uncompression happened. Finally, you will get a full-fledged operating system up and running in the kernel space. Okay, so that's how it is. Now what happened, right? And in the user space is a place where the user will log in. Suppose assume that here in the terminal I logged as a root user. So same way, what happened here? What happened? The user will log in here. The user will log in here. So suppose he's a root user, he will log in here like this. Root user logs in. So user space is a place where user will log in. So here you have logged into a terminal, right? So when you logged into the terminal, it is nothing but you are actually sitting into user space and working. So like this way, user space is a place where user will log in. Kernel space is a place where kernel will be up and running. Okay. So this RAM memory, it literally get into divided into two spaces, user space and the kernel space. Okay. This space, each and every space, right? This space, right? This space, each and every space, okay, it had its own entities. It had its own entities. It had its own features. We say it had its own entity. It has its own user space. It has its own. It has its own process address space. We say it, and also its it has its own memory mapping. We say these are some keywords I'm using. No, not to worry. So each and every space, okay, it had its own address space, it had its own memory. It means that what are the user space it is working, right? The kernel will know actually. Okay, kernel can even access what are the address space which are there in the user space. But what are the address space or what are the memory which is in the kernel space, the user space will not be able to understand it. Or he will not be able to get to know what is the kernel space on in which address the kernel is up and running, the user space will not be able to know it. So each and every space, it has its own privilege level, we say. It has its own memory mapping and it has its own address space. So each and every space has its own privilege level. It says that what is the privilege level means if there is any process or the thread, if it is running in the kernel space. Suppose there is a process which is running in the kernel space, or there is a task which is running in the kernel space. This is not but process or a task. This is not but process. It is running in the kernel space. Or if there is any process which is running in a user space like this. Suppose assume that this is one more process which is actually running in a user space. We say. So what the kernel will do, kernel will give a high priority to the kernel process rather than the user process. Oh, it says that, okay, first you execute this kernel process, later you execute the user space process. So that's the reason I say that each and every space, it has its own privilege level. It has its own memory or it has its own memory mapping or it has its own address space, we say. So it means that always the the system or the operating system will give the high priority to those processes which are not but the part of the kernel processor. So kernel processor or process which are running the kernel space, those processes will have a high priority than the user space process. Clear, guys? So that's how it is actually. Okay. So that's the reason what happened, right? It will divide it because it bifurcate. It will understand. Okay, kernel will is always running in under the protected mode. Kernel is always running a protect mode. Protect mode means nobody can harm to the kernel. No user can actually harm the data structure of the kernel, or nobody can harm in the up and running of the kernel. That's what the kernel will always be running the kernel space, and it will be running in a very highly protected mode. We say. And whenever any processes will get created in the kernel space, those processes will have a high privilege level than the user space processes. Okay, guys. So here in this user space, there are many users are there who will be logging. For example, like Rajesh is his own user account. Rajesh will log in. So where he log in? He will log in into user space only, right? He will sit here. He'll be working over here itself. Rajesh will be running. Similarly, Naresh is there. Naresh will log in here, or he will log in here. He'll be running. So as soon as Naresh logs into the system, right, he will be a part of the user space actually, and he'll be working here, sitting and working over here. Actually. Okay. So whenever this user he want to communicate with the kernel, whenever this user like root user or Naresh or Rajesh, anybody, they want to communicate with this kernel, or Rajesh want to communicate with the kernel, they can communicate only with the with the help of a what are the different methods are. One, the first method is that they can communicate with the help of a command. So whenever a user is executing any command, the user is actually communicating with the kernel with the help of a commands. Okay, what else? With the help of a API call or system call, we say. and with the help of a signals, or with the help of a proc file system. Here we say proc file system. So any one of the methods can be used, or you can even call the signals or interrupts we can call. So with any one of these methods, sir, a user can actually communicate with the kernel. So user always execute a lot of commands, right? So I'm executing, see, as a user, I'm executing the uname-r command. Right, sorry, I think I lost the. So you have seen that I have executed the Tty command, I have executed uname-r command. You have executed command, and the system has given output of that command, right? So it means that when a root user he is actually communicating or he's executing the command, he is basically communicating with the kernel. That's how it is. Okay, guys. So either using the command or API call or system call or signals or interrupt or proc system, any one of the method can be used from the user space to the kernel space to communicate. So you could ask that, is there any other method apart from this methods? No, there is no other method. You cannot communicate the kernel without these four methods. Okay, you cannot recreate some other new method where using that new method you can communicate. No, it's not possible. Only this four, or one more is the IOCT. Only with few of the methods only a user space process or user space or the user can actually communicate with the kernel. Clear, guys? So that's how it goes in here, right? So this is basically, it is nothing but when a system boots up, how exactly the RAM memory get divided. It get divided into user space and the kernel space. Usually we say that actually whatever the RAM memory we have, right? So 1/3 of the RAM memory is given for the kernel space. RAM size is given for kernel space, and 2/3 of the memory, 2/3 of the memory is given for the user space, like that. So this is a ratio, 2:1 ratio, always will be given. Okay, that's how it is, guys. So there are many things are there which we need to cover, but I think we'll stop it today here itself in the third session. In the fourth session, we will be like covering few more things actually, where we'll be explaining about what is the shell, how the shell comes into the picture, as well as what is the login shell and a non-login shell. There are many other concepts are there which we'll be covering as a part of the day 4 session. Okay, guys. Sure, thank you. So we'll stop it here itself, and we will cover the day 4 session by tomorrow or day after tomorrow. Hmm? Okay, Naresh. Chalo, Naresh, can you stop the session?
Yeah, yeah.